differential equation. So a differential equation an d raised to n y upon dx raised to n plus an minus 1 d raised to n minus 1 y upon dx raised to n minus 1 plus a1 dy by dx plus a naught y is equal to f of x. So a linear differential equation looks like this: d by dx. Look, d by dx here is derivative with respect to x. So I'm writing it as capital D, and this can be written in this form: an minus 1 d raised to n minus 1 plus a1 into d plus a naught bracket complete y is equal to f of x. So any linear differential equation we have seen that can be written as phi of t acting on y is equal to f of x. Now in this we have seen that solution of this differential equation is of the form y is equal to yc plus yp. Now if f of x is equal to 0, then the differential equation is called homogeneous linear differential equation, and in that case yp becomes 0. In the previous lecture we have seen it, and the solution will be simply y is equal to yc. So in today's lecture we will go ahead with finding out the solution for homogeneous linear differential equation. Okay, so to understand how do you get the solution for homogeneous linear differential equation, we have certain rules that we will follow, and in that way I can find out the solution for the differential equation. So before going to that, we will write down the definition for auxiliary equation. Auxiliary equation the auxiliary equation for a linear differential equation is for a linear differential equation phi of d acting on y is equal to f of x is given by phi of d equal to 0. So what I will do is, whatever differential equation we have, phi of d means the polynomial of derivatives acting on y is equal to f of x will be given by phi of d is equal to 0. Now, so the roots of the auxiliary equation, phi of d is equal to 0 gives the auxiliary solution. gives the auxiliary solution. So what we will have to do is we will have to find the roots of phi of d is equal to 0. Whatever are the roots, depending on that, we will write down the auxiliary solution. Auxiliary solution is denoted by yc. So I will write down the cases now. So we have seen that. I mean, phi of d we know that is a polynomial. Phi of d is a polynomial. Is polynomial. Is polynomial.
Sir, sir,
Yes.
sir, two students are waiting for coming in. Please accept them.
Okay. So phi of d is a polynomial, and whatever is the degree. If n is the degree, n is degree, then n roots will be there. N roots exist. I mean, real plus complex or repeated, all of them. So if n is the degree, I will get n roots. So whatever is the nature of the n roots, nature of n roots of n roots define the solution. Roots define the solution. Okay. So now what I will do is I will consider the cases, whatever cases are there. I mean, you are well aware that the roots can be real. So what are the choices? So roots are real roots can be there. Okay. So there can be say three roots and uh, three are real. Then there can be complex roots. We have seen one example where we had one, but it was repeated twice. Okay. So real and repeated roots can be there. Real and repeated can be there. And the last choice is complex repeated roots. Complex repeated roots. Okay, so you give me any polynomial. When I find out the roots, uh, there can be only these four cases. So I will have either real roots will be there. It can be combination of some real and some complex. It can also be the combination of real and repeated, also complex and repeated. So we will see what happens when there are these cases, and we will see how we will write down the solution. We don't have to do any kind of derivative or integration. So the case number one, case one, real and distinct. So if phi of d is equal to 0 as m1, m2, m3, and mn as real and distinct roots, and distinct roots, then yc will be equal to c1 e to the power m1x plus c2 e to the power m2x plus c3 e to the power m3x dot 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 Cn e to the power mn of x. So what you are going to do, you will get the differential equation. You will make the auxiliary equation out of it, taking y common. And once you take y common, then you will get the auxiliary equation, find the roots of auxiliary equation. Then I will observe, are the roots different, all of them? With being different, is it happening that all of them are real? So in that case, real and different roots, then what I will do is I'll take C1 e to the power first root into x plus C2 e to the power second root into x, C3 e to the power third root into x, whatever number of roots you have, real and distinct. So this is the first case. So for an example, say I have simply solve d cube y by dx cube minus 6 d2y by dx square plus 11 dy by dx minus 6y is equal to 0. Okay, so this is my linear differential equation. So what I am supposed to do, I'll take y common. So d cube by dx cube minus 6 and d2 by dx square plus 11 dy dx minus 6 y is equal to 0. Once I do this, what I have to do, d by dx is capital D, so that will be d cube minus 6 d square plus 11 d minus 6 y is equal to 0. So what is my auxiliary equation? Auxiliary equation d cube minus 6 d square plus 11d minus 6 is equal to 0. So once I have the auxiliary equation, what will I have to do now? I will have to find the roots of this auxiliary equation. Okay. So there is another screen I will be sharing. With that, I'll tell you okay, which how to use that calculator now. So go to the look. In your calc, what you will have to do is you press mode. Once you press mode, you will find out the equations. In that equation, you choose the form which is given here. Second form you can see on the screen, ax cube plus bx square plus cx plus d equal to 0. Okay. Are you with me? So in your calc, what you do is you press mode. Once you press mode, later you will have to take equations. In that equation, now you can see on my mobile screen that ax cube plus bx square plus cx plus d equal to 0. This kind of equation will be there. Okay. Now I will select this. So in your calc, what it will ask is, in some of the calcs, it will ask the value of a. So I will enter the value of a. The value of a is the coefficient of x cube, so it is 1. In your calc, you press equal to. Once you press equal to, then it will go to the next entry, the value of b. The value of b in our equation is -6. Then c is the coefficient of x. In this case, it is 11. Again, you press equal to. Then the cursor will shift to the next entry. The last one is again -6. So what I've got is, I've got three roots. X1 is 3, x2 is 2, and x3 is 1. In your calci, it will in some of the calces it will show just one root. In some of the calces it will show more than one root. I mean, all three of them at the same time. So what you have to do is you have to go on pressing equal to. Look, this is a very important method if you are, I mean, worried about M3. So your calci will play a major role. So what you have to do is you have to learn how to find the roots of this equation, degree 3. Okay, so 3, 2, and 1, I have three distinct roots. Okay, so I will write down the equation roots now. Roots are 3, 2, and 1. Okay, so the roots that I have got, those I have got are 3, 2, and 1. Now, all three are real and distinct. So, the solution yc is equal to c1 e to the power 3x plus c2 e to the power 2x plus c1 e to the power 1 into x. Now, since given a linear differential equation is homogeneous, y will be simply equal to yc. So y is equal to c1 into the power 3x plus c2 e to the power 2x plus c3 e to the power x. So this is how you find the solution. I hope it is clear. Raj,
Yes, sir.
uh, you have tried it on your calci?
Yes, sir.
Okay, fine. So we will go to the next case. The first case is clear when you have real and distinct roots. So we will go to the next case where you have complex roots. So case number 2. So if for the auxiliary equation phi of d is equal to 0, we have complex and distinct roots. Complex and distinct roots. say A1 plus I times B1, comma A2 plus I times B2, so on, whatever. An plus I times Bn. So I have a small question here. Is it possible that these can be the roots A1 plus IB1, A2 plus IB2, or there need to be something else too? Yashovardhan, degree say I'll take 4. So you will have to remember this. I mean, whenever A plus IB is root, A minus IB is also the root. So whenever some equation will occur where you have a complex root, so both pairs will be there. I mean, if 1 plus I is the root, then 1 minus I is also the root of that equation. So this is a famous theorem which says that complex roots appear in conjugate. Okay, so this kind of thing will be there. To make this thing easier to understand, what I will do is, if for phi of d is equal to 0, we have a1 plus minus I times b1, comma a2 plus minus I times b2 as the roots, then what degree phi of d should have? Anyone? What should be the degree of phi of d if a plus minus ib1 and a2 plus minus ib2 are the roots?
1.
Why 1? Dhruv. Janvi, what degree it must have? Shashwat,
Sir, I think 3.
Yash. Yash, why 4?
Sir, four roots, no? Four. So
Yes,
degree must
yes,
be 4.
yes, very good. So the number of roots we have are 4, which means that a1 plus ib1, a1 minus ib1, a2 plus ib2, a2 minus ib2. So we have 4 roots. So 4 roots can only be for a polynomial with degree 4. So for this complete pair a1 plus ib1 and a2 plus ib2, this is one pair. And for this complete pair, we will write one solution, and for this complete pair, I will write one solution. Then yc will be equal to c1 cos b1x plus c2 sin b1x e to the power a1x, plus for the second pair, I am writing c3 cos b2x plus C4 sine B2x e to the power E2x. So what we have done, if I have a1 plus ib1 as the root, then cos b1. So imaginary part comes with sine and cos. Okay. So imaginary part of this complex number is the thing with I. So b1 is with I. So for this b1 comes with cos and sine, and the real part a1 comes with the power e to the power a1x. For the second pair, you can see that the thing with I is b2. So b2 will come with cos and sine. So cos of b2x, sine of b2x. And the real part of the second complex number a2 is e to the power a2 into x. So this happens when you have complex number, distinct complex numbers as the root. So again, one small example based on this. Say, solve d square plus 2d plus 5 y is equal to 0. So what will be the auxiliary equation for this? Auxiliary equation is d square plus 2d plus 5 is equal to 0. So whoever have the calci and have understood what they have to do, how to find the roots, can go ahead and find the roots of this and tell me the value of d.
Sir, -1 plus 2i.
Yes, -1 plus 2i and the other one degree 2 है ना, तो दो रूट्स आने चाहिए.
-1 -y.
-1 plus 2i, comma,
And -2.
-1 minus 2i. Okay, these are the roots. So I said that for this pair, I mean, we will write just one solution. So yc is equal to c1 cos. Cos के साथ क्या आता है? The thing with I, what is there? 2. So 2x will be there plus c2 sine 2x, and then e के साथ आएगा real part -1. So e to the power -1 into x. So this is your auxiliary solution for this, and the differential equation is homogeneous, so y will be equal to yc. Okay, so this is how you write down the roots when you have complex. So we'll go to the third case. The third case is if you have real and repeated roots. So case number 3. So if the roots of auxiliary equation phi of d equal to 0 are real and repeated. So in that case, now what will happen is, say, so I will make a sub case 1 here, just for a better understanding. So if the roots are like this, say m1 comma m1, m2, m3, m4. So all are real, but which one is repeated? M1, I can see that it is repeated, and M2, M3, M4 all are distinct. So in that case, Yc will be equal to C1 plus C2 x e to the power m1x plus C3 e to the power m2x plus C4 e to the power m3x plus C5 e to the power m4x. तो what I have done, जो distinct है उसका तो हमने structure same रखा है, so I can see that here. So M2, M3, M4 all are distinct roots, real and distinct. So the structure is simply followed with the case 1. In the case 1, I said that if those are real and distinct, then this structure will be followed. Now what is happening? M1 is repeating itself one time. So what I have done, C1 plus C2x. So as the number of times it will repeat, I will increase the constant and multiply one more x. So on the same line, if the roots are like this, m1, 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 m2, m3, m4, or simply m2 and m3. So what is happening now? What is the difference? Now m1 is not just repeated once, it is repeating thrice. So in that case, yc will be equal to c1 plus c2x plus c3 x square e to the power m1x plus c4 e to the power m2x plus c5 e to the power m3x. Okay. So if it is repeating thrice, then c1 plus c2x plus c3x square. So what is the idea? Every time a number increases, I am taking that many constant and increasing the power of x. Mean to say, if there are 3, m1 is repeated thrice. Okay, so I have 3 constants over here, c1, c2, c3. If m1 was there 2 times, then c1 and c2 is there. And I'm increasing the power of x starting from 1 x square. So in the third case, m1, 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 and the last one is just once m2. So now m1 is repeated 4 times, so yc will be equal to, I will have how many constants? 1, 2, 3, 4. और हर एक constant के बाद में power of x has to increase. So c1, c2x plus c3x square plus c4 x cube e to the power m1x. And m2 is again a distinct root, the real one, so e to the power m2x. And so I hope it is clear. So we'll solve a small example based on this. So example, solve d minus 1 cube d plus 1 y is equal to 0. So auxiliary equation for this will be d minus 1 cube into d plus 1 is equal to 0, which means that d minus 1 cube is equal to 0 or d plus 1 is equal to 0. So d minus 1 cube hai, which means that d is equal to 1, comma 1, comma 1. So 1 is repeated 3 times, or d is equal to minus 1. So the roots are 1, comma 1, comma 1, comma minus 1. So 1 is repeated. How many times? 3 times. So I should have 3 constants. So yc is equal to bracket c1 plus c2x plus c3 x square. This is for the repeated one, e to the power 1 into x plus c4 e to the power minus 1 into x. So this is the solution. Since the given differential equation is homogeneous, y is equal to yc is equal to this. So I hope it is clear. And then we'll go to the last case. The last case says that the roots complex root is repeated, then what we will have to do, the idea is same. Okay, so with each increased repeated root, you multiply by x. So case number 4, if the complex root is repeated for the auxiliary equation. And say what I will have is m1, the first root is say alpha plus I beta. With this, you will also have the second root alpha minus I beta. As we have seen, complex roots always appear in pair. Third root m3 is again alpha plus I beta, and m4 is alpha minus I beta. So for complex roots to be repeated, minimum degree has to be 4. Okay. So now alpha plus I beta is repeated, as I can see. So yc in this case will be, so c1 plus c2x cos of beta x plus c3 plus c4x sine of beta x e to the power alpha x. So as you can see, what I have done, with each repeated root, I have increased the number of constants. Because if you remember, the number of constants in a general solution is always equal to the order of differential equation, which means the power of, the degree of your polynomial. So these are the 4 cases. We'll solve 2 to 3 examples. So you will have to take out your calci and do the working with me, because these are small examples and many can be asked in your MCQs. And as we are in online platform, yeah, maybe end term can be with MCQs. So it is highly recommended that you use your calci right now to make yourself comfortable. Example 1. Solve d2y by dx square minus 5 dy by dx minus 6 y is equal to 0. So what we have to do, take out y common. So d2 by dx square, I shouldn't use the word common, but yet I will be using it since it is better for understanding. Minus 6 y is equal to 0. Once we do this, write down d by dx as capital D. So this will be d square minus 5d minus 6y is equal to 0. So what is the auxiliary equation now? Auxiliary equation is d square minus 5d minus 6 is equal to 0. So quickly do this on your calci. And what are the roots?
6 and minus 1.
Yes. The roots are 6 comma minus 1. Once you get the roots, identify in which case this fits in. So 6 and minus 1 both are real and both are different. So yc is c1 e to the power 6x plus c2 e to the power minus 6. Okay. Next example. Number 2. Solve d cube y by dx cube plus 2 d2y by dx square plus dy by dx is equal to 0. So you can do the middle calculation now, as we have done a lot of examples. So I will directly write down auxiliary equation. So auxiliary equation for this will be d cube plus 2d square plus d is equal to 0. Anyone, what are the roots?
0 and minus 1.
0 and minus 1. So Dhruv, degree is 3.
Yeah.
So what will happen now? Which one is repeated? Because look, I should have a list of 3 roots. So I should be able to identify which one is repeated. Okay. So I will tell you a technique by which you can identify. You can take the derivative of this. What is the derivative of this equation? D cube plus 2d square plus d. So that will be simply 3d square plus 4d plus 1 is equal to 0. Okay. So this is the standard technique. Jab bhi you will have to check which one is repeated. What you will have to do is you take the derivative. Now you put 0 in this. So if I put 0 in this, so 3 into 0 plus 4 into 0 plus 1. Is the equation satisfied? No. So 0 is not repeated. 0 is not repeated. अगर कोई रूट रिपीटेड होता है तो डेरिवेटिव विल आल्सो हैव दैट रूट. So we will simply identify, put -1 then. Put -1. What will happen? 3 into -1 square, LHS is equal to plus 4 into -1 plus 1. So 3 plus 1, 4, minus 4, answer is 0, which is equal to RHS. So this tells me that -1 is repeated, because -1 is also the root of its derivative. So this is the way you will have to check. So YC will be equal to, so YC is equal to 0 is different, so C1 e to the power 0x plus, now -1 is repeated 2 times, so I will have to take the constant C2 plus C3x e to the power -1 into x. Now since it is homogeneous, y is equal to yc is equal to e to the power 0 is 1, so c1 plus in bracket c2 plus c3x e to the power -x. Done. Next example, third one. Example number 3, d cube plus d square minus 2d plus 12 y is equal to 0. Auxiliary equation is d cube plus d square minus 2d plus 12 is equal to 0. This gives me d is equal to
-1 and 1 plus root under root 3i.
no. Please check it once again.
Sorry, -3 and 1 plus under root 3i.
1 plus under root 3i. So only plus won't be there. With that, there will be -2. Don't forget this. So you have real root and you have a complex root. Complex root is not repeated. So case number 2 is the solution.
Why did you take my root 3?
Yes,
Why did you take root 3?
it is there in the roots.
I didn't understand that.
Which one? Which one? Please repeat your question.
1 plus under root 3i. I didn't understand how you got that.
1 plus under root 3.
Yeah.
It is in your calci, right? It is displayed on your screen.
No.
With the version of your calci may be a bit different. So you press this on your calci. There must be this A plus IB button. You look at the buttons. There must be somewhere written A plus IB, and press that. Then once you press that, it will show you the imaginary part also for that complex number. In some of the calculators, it doesn't show you complete complex root. You will have to work on it.
I got the answer as -311.
-311. That's what I'm saying. In that calculator, it doesn't show you this imaginary part immediately. I mean, with 1. With 1 और कहीं पे ऊपर left hand side और right hand side में there must be written I. Please check it.
Yes.
Yes, it means that it is a complex number. So to look at imaginary part on your keyboard, I mean calculator keyboard, You will have to find out a button a plus ib. Then it will.
Yes, sir. It comes like x1 is equal to -3, then x2 is 1 plus root 3, and 1 minus root 3. It comes on the
Yes.
calculator.
Yes. In some calculators it doesn't show. So you will have to work with it a bit.
I have a
Okay.
button which has I symbol.
Yeah. Press it. See what you get. Is
Nothing.
it showing under root 3?
No.
Uh, okay.
Do I have to go to complex mode?
Yes, you will have to work with it something. So you will have to check group. Okay, while checking out the roots, you have to check the corners. Is there I? And I don't have the calci actually with me right now, or else I would have told you the command also. I don't remember. Okay, so try to find it out, or else I will also see if I can get help you something.
Okay, sir.
Okay, yeah. So the roots, those are -3 and 1 plus minus root 3i. So yc, which is also equal to y, being homogeneous, for the real root c1 e to the power -3x. This is real. Okay, so it is like this. And for the complex, for this pair, what we'll write, c2 cos of the imaginary part root 3x plus c3 sine root 3x e to the power x. Okay. The last example, in example number 4, 4 d square plus 1 whole square, a whole cube actually, and d square plus d plus 1 whole square y is equal to 0. So the auxiliary equation for this will be d square plus 1 cube into d square plus d plus 1 whole square is equal to 0. So multiplication of two brackets is 0. So it means that the first bracket has to be 0 or the second one has to be 0. D square plus 1 cube is equal to 0, or d square plus d plus 1 is equal to 0. This square. Okay. Now, what do I mean by d square plus 1 cube? It means that जो d square plus 1 equal to 0 है, ये जो roots आएंगे, those are 3 times. I mean to say like this. And d square plus 1 is equal to 0, or d square plus d plus 1 is equal to 0, comma d square plus d plus 1 is equal to 0. Now what are the roots of d square plus 1 equal to 0? What are the roots? D square plus 1 equal to 0.
Sir, I or minus I.
I minus I. How many times I and minus I are there?
1.
Only one for the first one. For this one, 2, there is plus minus I. For the third one, 2, it is plus minus I. So how many times I is repeated?
3.
3 times. And the other one, d square plus d plus 1.
minus 1 by 2 plus under root 3 divided by 2I.
Yes. Minus 1 plus minus 1 by 2 plus minus under root 3 by 2I. And this is also repeated twice. You have d square plus d plus 1 two times, right? That will be minus 1 by 2 plus minus under root 3 by 2I. So I is repeated 3 times. Minus 1 by 2 plus root 3I is repeated 2 times. So y is equal to yc. So I will write down the solution for these three things first of all. So 3 times repeated I. So 3 constants I have to take in consideration. C1 plus C2x plus C3 x square cos of imaginary part into x, 1 into x, plus C4 plus C5x plus C6 x square sine of x e to the power real part into x plus now minus 1 by 2 plus root 3 by 2I. It is repeated 2 times, so constants will be 2. So 6 is covered. 6 C7 plus C8 x sine, cos root 3 by 2x plus C9 plus C10 x sine of root 3 x by 2 e to the power, a real part is minus 1 by 2 e to the power minus x by 2. So this is the final solution for this. Clear? So that is all about homogeneous linear differential equations. In the next lecture, we will solve some non-homogeneous linear differential equations. That's all for today. If you have any queries, you can ask.
No, sir.